I want us to do an electrolysis by using the diagrams of the components that are needed. That is our beaker. Do not worry about the ugliness of the beaker. I'm not a perfect drawer. First of all, we make ionic solution. Ionic solution. That is ionic solution. And then after making ionic solution, we take two pencils, we sharpen them. When we sharpen them, we also look for the cardboard. That cardboard, we make 2 holes on them, and then we put it on top of the beaker, and then we place the 2 pencils that we've sharpened. 2 pencils that were sharpened. And we make sure that the 2 does not touch each other. These 2 must not touch each other. And the pencils must also not touch the side of the beaker, because it will affect the process of separation of the compound. Remember, we are proving that the effects of electric current can cause a chemical reaction, which means that it can allow current to flow inside the chemical solution or ionic solution. It can cause chemical reaction. Remember, in grade 8 term 2, we learned about elements in the periodic table, and we took those elements. If we take 2 of the elements, they go through chemical reaction, they will form a compound. So we will take the compound, 2 elements, which is copper and chlorine, and make them go through chemical reaction, and they will give us copper chloride, and which is blue in color. And then that copper chloride, well, is going to be used, and when it's used to do this practical, in order for us to understand. And then I will take my cell and connect with conducting wires. Oh, let's take my pencil. I sharpened it up to here. Conducting wire. That's my cell. Don't worry about the ugliness. That's my cell, and that's my conducting wire. Please, this one, don't mind it. Is the one that I thought I'm trying to draw. I was using the electrodes. So what do we call these pencils that we have sharpened? We call them electrodes. These are electrodes. As they are electrodes. And then here we have got what? Ionic solution. And this is the conducting wire. So this is the cell. What is the function of the cell? The cell store energy. The cell store energy. It stores chemical potential energy. It stores chemical potential energy. Once the energy we have connected. Now the energy is starting to move from the cells through the conducting wire. In the conducting wire, it's no longer called electric chemical potential energy. It's called electric current. As the current flows, it flows and flows and go down. Here it will be. Remember, now we must show this is a we start by showing that the electrode, first of all, the cell here is positive, here is negative, and here the electrodes, this one will become positive, this one will become negative, because it's connected to the positive, and this one is connected to the negative. They will both be positive and negative side. And then not forgetting that we say that unlike charges attract each other. So that one, if you know that copper is positively charged and chlorine is negatively charged, do not assume that copper and chlorine will attract each other. No, it is wrong. The learners have got a problem. You, my grade 8, have got a problem that you think that copper and chlorine will attract each other. No. This is a compound when it comes here. It's an ion now because it has a charge. The reason why we call it an ion is because it has a charge. Copper has a positive charge and chlorine has got a negative charge. And then as it's an ionic solution, once it is here, it is separated. It's no longer copper chloride. It's copper ion and chlorine ion. And then, so current will flow. When current passes here, copper will come here. And when copper come here, it will be a deposited brownish discharge. We call it brownish discharge, which is deposited on the negative charged electron. Negatively charged electron is called a what? Electrode is called a cathode. It is a cathode. And then this one is called the what? The anode. This is the anode. Is the negative, is the positive charged one. It has a positive charge. Is the anode. This one is the cathode. So the cathode, when current flow via the cathode, it will pump copper because copper is positively charged and this one is negatively charged, the cathode. So it will pump the copper to the negative electrode called cathode. And then after being charged, this one, current will be moving towards this one because it has got a what? A positive charge. Remember, electrons jump from one to another. Again, one object to another. So it is jumping from the negative one to the positive one. So as it moves here through this one, it will take chlorine. And chlorine here, what will we see? That chlorine is being pumped by the anode. It will be having bubbles of gas around it. So the bubbles of gas is a sign that this is what? Chlorine gas bubbles. So the chlorine gas bubbles are the ones that will show on the anode, the positive charge electrode. And then that is what process here that we call electrolysis. Electrolysis is when electric current passes through a solution called ionic solution. Ionic solution, remember, is the solution that have got a charge in it. I showed you how an ionic solution is in the previous video, how to make an ionic solution. This one. So please be very, very careful to understanding this. And don't confuse it with decomposition of compounds in term 2, where we are understanding current can flow through the ionic solution. It's the proven now. It's proven now. So please don't be confused. We did decomposition in term 2, separation of mixtures by using electricity. Now we prove that electricity can pass through what? An ionic solution. So you understand. Don't be scared. This is electrolysis. Don't be scared of it. Love it. It's so nice. Understand this if you know that. And you know this copper chloride, what we call it after. You'll understand. This is the same elements that we take from the periodic table and we form a compound. And then after forming a compound, and then we separate them by using electricity. Meaning we are decomposing them by using electricity, but we are not doing decomposition. We are not on that one. We are proving that current is the effects of current. Effects of current in a solution. Okay? Current can pass through. Thank you. Danko. See you next time.